The notes, they're right there. Okay, so today, let's go ahead and do this. Today is 2-2, huh? Oh, man. It is 2-2-22. Wow! Now that's a math problem, huh? So what's our objective? Today what we want to talk about is functions and piecewise functions, okay? All right, before I talk about functions, I want you to just think about this. Think about this. Why do we even care about functions? What's the big deal, right? Same thing with absolute values. Yesterday we talked about why absolute values are important, right? Because if you're a machine, you can't go to Kashmir 12 miles away and then come back from Kashmir and have negative 12 miles. There's no such thing as negative 12 miles, right? So you have an absolute value that tells you whatever goes in has to come out positive, right? Some things have to always be positive, okay? Now functions. I'm going to give you an example, okay? You're at the cash register, somebody buys a really nice coat, you ring it up, you hit the cash register, and all of a sudden 2 different prices pop up. So you got one coat with 2 prices. Doesn't make sense. I'm driving down the road, and I've been driving for 3 hours. Think about this one. I've been driving for 3 hours. Think about this one. And all of a sudden, I'm 150 miles away from home, and 200 miles away from home. No, wait a minute. I drove for 3 hours, and all of a sudden I'm 150 miles away from home and 200 miles away from home. It doesn't make sense, does it? You come to Bill's latte stand. You want a latte, right? So Teva says, what do you say, Teva? I want to buy a latte. And I say, Teva, that's $5. That's $6. It's $5. How can one latte cost 2 different prices? You're going to say, I'm going to take the cheaper one, right? Agree with that? So some things you have to have one and only one answer. Mostly, right? So functions, now remember, we're talking to machines, not people, because people are like, oh, come on, this is dumb. Machines don't always think like we do. So, in order to be a function, every x value must have only one y value, okay? If I had more time, we'd do the latte stand, Teva. We're running out of time. So, but I do want to do this, okay? Time, distance, okay? Time and distance, okay? So I call you up. You're on the road. You've been driving for 3 hours. You're my kid. I want to check on you. So I say, hey, Landon. Dude, where you at? You've been driving for 3 hours. I said, well, Dad, I think I'm 150 miles away from home. No, maybe I'm 200 miles away from home. It just can't be both. You guys agree? So you've got an x value with 2 y's. That is not a function. That is not a function. So, to be a function, every x value has to have exactly 1. So one of the things I can see is that this is not a function. So we have this thing called a vertical line test. And if you can draw a line anywhere on the graph, if it hits the graph more than once, then it's not. So the vertical line test is something you just draw a line straight on down. If it hits the graph at more than one point anywhere, it's not a function. Okay, does that make sense? So a function's got to have 1x, 1y. All right, so let's take a look at these graphs. So what do you think? First graph. Is this a function, yes or no?
Yes.
So it looks to me as if I have an x value and 1 y value. An x value, 1 y value. But the easiest thing is I never see where it would ever hit the graph twice. So I'd say yes, that's a function. Heck yeah, that's a function. Is this one a function?
Yes.
Yes, it looks a little tricky there, but I'm pretty sure that you've got 1x with one y, okay? Ava, here's the one. Okay. So that's definitely a yes. I'm going to say yes. Now if I take a look at this, there's one of them that's not a function. Which one? Anna, go ahead and say it. You're looking at it, you're pointing at it. Would you go that one with the question mark? You guys see the question mark? That one's not a function. Why is this one not a function? Go ahead, Grace. Boom, boom, right? You can't be, at 1 hour driving, you can't be in 2 different places. Okay, I'm sorry, it doesn't work that way, right? Nice job, Grace. This one's the no, and this is a yes. And this one here is what we want to talk about specifically. But this one's also yes. This one will work. Because open circle means it doesn't open it. So right here, this one's also a yes. Yeah. You guys get it? Did you get the homework?
Isn't it page 10?
Yeah, I think it's page 10, 1 through 9. Yeah.
Okay.
So this one's a yes also because it passes through here, hits there, and that's a yes. All right, so one more time. I think the easiest way to remember what a function has to be is this. You get in the car, you drive for 3 hours. I call Lana up, I say, hey Lana, where you at? 3 hours. Where you at? Well, Dad, I think I drove 150 miles, maybe 200. Which one is it? It can't be both. You guys agree? So 1x is only one answer. One answer. Why are functions important? Because so much of what we do is dealt with machines. And machines aren't smart like we are. Yeah, they can do things really fast. Machines are not smart like we are. So we have to be able to tell a machine what a function is. Okay, so now turn the page and let's talk more about a piecewise function, okay? So a piecewise function is two or more functions together. This is a piecewise function. In fact, I see 3 pieces. You guys see 3 pieces? So one graph here, second graph here, and third graph here. Okay. Where are the piecewise graphs separated? So this is really important. The first thing I like to do when I do piecewise graphs, I like to just draw in where they are separated. Okay. So I have 1 graph, 2 graphs, and 3 graphs in 3 different regions. Okay? You got graph 1, graph 2, and graph 3. 3 different regions. You guys see that? So then, if I want f of 0, again, it's like f of x, right? So we've been talking about f of x, and when f of x means it's a function. F of x, this is our symbol for saying a graph. A graph is a function. Okay, so let's talk about that real quick. So altogether, is this a function? Oh, we might have a problem right here. Oh, we don't, do we? Looks like we might have a problem right here, but we don't, okay? Now right here's a little weird, but we're going to talk about this one, okay? We're going to talk about this one specifically, okay? All right, so it is a function, but to 3 pieces. Now, if I want f of 0, I go, instead of f of x, I want f of 0. I go to the x-axis, okay? Go to my x-axis, and I find 0. Okay, so I find 0. That's right there, right? What's the y value? 1. Yeah, that's the answer. Awesome. Perfect. That easy? Okay. F of 4, what's F of 4? What do you guys see F of 4 is? X, there's 4. It's 4. What's the height? The corresponding y value, okay? How about F of negative 2? It's not this one, right? Because that's got a hole. It's got to be, right? That one's going to be a height of 2. So let's write those down, okay? So I have f of 0, we said is, f of 0 was 1, right? F of 4 we said was 4. F of negative 2 is not here, but it's up here at 2. Okay, thumbs up so far? Okay. Now, let's look at the next example. Now, the next example, we don't have graph of it. We could graph it, and I will graph it, but not today, okay? Tomorrow, we're going to graph this. I'll give you a rough sketch. I'm just going to really throw it in rough. Here's kind of what it looked like. Let's see, 1, 4. Just watch. 1, 4. So, and we're going to do this tomorrow, but I just want to give you a kind of clue what we're going to do tomorrow. Okay, so negative 2, height of negative 2, that, plus 4, and then down over 1, negative 1 and 1. Oh, I got that one wrong. 1 and 4. Oh, this one's up here. This one's up here. This one's going on. Yes, you got it. What are you doing, Mr. Davies? Just watch. We're going to do this tomorrow. And then 3. It's kind of like this graph looks like, okay? Hey, now if that freaked you out, don't worry. This is what we're going to do tomorrow, okay? But I want to give you a little clue. This is going to look something like this. Now, if I do a really nice, neat job, which I will tomorrow, I'm going to show you how to do this tomorrow. But today, I just get rid of it, okay? So that's why it's a 2-day lesson, right? So here's the deal. We can't plug these numbers into the graph, right? But g of 0, gotta look at this. Right? 0 is your x values. These are my boundaries, okay? 0 fits right into here. Okay, look. Negative 1 to 1, 0 goes here. You agree? 0 wouldn't go here because 0 is not between 1 and 4. 0 doesn't go here because 0 is not less than 1. So the 0 fits in here. So the 0 fits right in here to that graph. So plug the 0 in for x. Okay, I'm going to do this again, but I'm going to do it from there. Okay, so here's what you do. You find where it belongs. Okay, so we got to find where it belongs. So at g of 0, we find the interval, and for g of 0, it goes right there because 0 is between negative 1 and 1. Everybody agree with that? So then I'm going to plug it in. So I'm going to plug it into g of 0 is equal to negative 0 plus 4. So I plugged it into its equation. The answer is 4. G of 3. Well, where does G fit? Interval, first interval, second interval, or third interval. Where does 3 fit? First interval, second interval, or third interval. Where does 3 fit? First interval, second interval, or third interval. What do you think? Where's the 3 fit? Is 3 between 1 and 4, or is 3 between negative 1 and 1, or is 3 less than negative 1? Well, it's got to be 1. It's got to be. 3, the number 3 is definitely in between 1 and 4. You guys agree with that? So I'm going to plug it into this equation. So I've got a g of 3 is equal to, well, negative 2. There's nothing to plug it into, so the answer is negative 2. G of negative 1. Is negative 1 between 1 and 4? Is negative 1 between negative 1 and 1, or is it less than negative 1? Does it go into the first interval, the Second. Good job, Tave. That's right. It's almost tricky, isn't it? Anna, you said it earlier. Why does it have to go into the second interval, not the first? Say it again for me, please.
Because greater than or equal to.
It's the equal to, right? It's the equal to. So -1 is equal to -1. Do we agree? -1 is equal to -1, but -1 is not less than -1. So we have to plug it into the segment. So put -1 right there. -1 will be right there, inference x. So I'm going to use equation 2 because it belongs in interval 2. So, all right. I'm going to put it in. So g of -1 is equal to a -1 plus 4, right? Because I plugged it right in there. Double negative makes 1 plus 4 is 5, okay? All right. What do you think? Today, and homework is in your book, in your journal, page 10. We're going to do 1 through 9 only, okay? And then tomorrow.